economy. I recall the era of utility furniture. And the point about furniture is that one had to minimize on materials, but also that you don't put it inside containers or bridges or boxes. You put it inside habitable buildings. And therefore it seems to me that one has to have a certain liaison between the architect and the engineer, which I would like to develop briefly in a moment. Before doing so, I want to comment upon the spectacle I saw in Norfolk, Virginia, of lorries carrying what I thought were wooden beams. They turned out to be made of concrete with polyester fiber inside them because they were wobbling up and down like this. I could hardly believe they were concrete. They were intended for the construction of a new tunnel. I examined them. They were indeed concrete. Now what does that tell me? It tells me I can bend this stuff around like that. Isn't that beautiful? If I look back at the 1870s or even 1830s, I can see the precursors of Fuller or whatever, tensegrity and so on, in some of those beautiful diaphanous structures. If I look at minimalization, it can be of that sort, or it can be of the sort of clod-hopping sort, which makes structures which are, by all criteria of habitation, uninhabitable, by token of St. Louis. But the main point I'd like to make, and this is, I think, a serious point, is that in considering structural representation, structural expression, we have forgotten the fact, perhaps, or maybe have omitted the fact, that a certain sense of priority has been fundamentally reversed. Now, if I wanted to set up a house, I would get first a telephone, or a telegraph as I was, and build a carapace around it when I had enough money to do so. Previously, I would build a carapace, a hut, and I would bring in the telephone. Cedric will bear out my philosophy, I'm sure, on this, because we cooperated in a recent project, not terribly successful, but that was probably because we reversed our roles and he did the information and I did the architecture. And we didn't consult enough on the engineering. It's interesting that if you try to build an information environment in which we live now, I am an information engineer. I'm also, as a matter of fact, a mining engineer. But I'm an architect of knowledge. And herein is habitation. Herein does the beauty lie. Herein does the intellect, not the intelligence, the intellect reside. That is a profession, I do believe.
Thank you.
Yeah.
Sorry, David, your slide's ready?
Yep. I didn't want to talk about, I mean, I find the whole idea of structural expressionism terribly dull. It belongs to a period of dead architecture for me, when people were looking for some notion of truth vouchsafed by somebody else. And if I think about the notion of expressionism, I would say that which is the thing that would interest me most, it would occur in the 20s. This is Alfred Barr's cow of art and architecture. You'll see expressionism is in there someplace, on the left-hand side middle. And the kind of expressionism which I find interesting, which I never find in structural expressionism, is, I don't know if the lights could go down a bit. This is an Otto's painting called Homage to Beauty. That's great. It's something to do with the city. Something to do with loving and hating it and finding it hard. This is Dix's very ironic object. And when I look at sort of buildings that are produced at the time of the Dix painting, like this Bruno Taunt scheme in East Berlin, you can see that the building, I don't really think expresses any structure, but it's certainly modelled on the notion of Berlin. It has in the middle a wide boulevard, and then, which you see here, off that, a narrow street scaled to the normal street scale in the centre of Berlin, and in between that are allotments. Also something I find quite interesting. The building doesn't express itself, it does say something about the city. I think what is disgusting about the architecture of New Brutalism and structural expressionism has always been that it wants to produce an individual monument. It's basically greenfield site architecture, has very little to do with the city. And I find this very depressing. Having said that, I think that what's happening to Nick Grimshaw's scheme of Waterloo is absolutely disgusting, but does indicate, in the sense of what British Rail want to put on top of it, but does indicate the absolute problem of a structurally conceived scheme. Because now there's going to be this awful office building on the top of it, which comes right through, which means that there's no reason anymore for this big span because of the big columns of the office, I assume. And I'd like, while I deprecate structural expressionism, but I love engineering, I'd like to suggest that now we start a petition in defence of Nick's building, because what British Rail is suggesting is just gross and has nothing to do with the city. Thanks.
Okay, now, would John like to join in on this stage?
Right. I've got some slides in there.
Okay. John Pringle.
Thank you. Forward.
Yes.
Blue dot.
John Pringle.
Thank you very much. As informative as ever.
Okay. Actually, I think structural expression seems to imply that there's a fantastic ready-made menu of structural ingredients that you can feed into your building. But in fact, we find this rather the reverse. It's we spend more time trying to get them out, because especially with our buildings, where we are have a very slim buildings where everything is taken back to the bones. One can't afford to have any structure which is in inconvenient places. I think the thing that's most important to us is actually the software aspect of structure. It's the way of looking at buildings to really achieve what you want to do, and to try and do what looks obvious and to then justify it later. It provides the software that enables the buildings to happen. And really, structural engineering is only one aspect of it. In our buildings, I think we'd like to see that structure is obviously a very important ingredient, but there's also the thermal engineering and the constraints of the site. And there's really a whole stew of things that you put all the ingredients in, and you let them cook during the design process, and they sort of come out with some ingredients that have been sort of boiled away over the process of the project, and there's just a hint of the flavour of them left, but some of them remain as very strong influence at the end. And structure is obviously going to be one of those things that remains throughout the project. In fact, if we take Lord's Cricket Ground, which is has some fairly expressive bits of structure above, apparently. To me, the most wonderful bit of engineering is, in fact, right under the existing terrace, which, if we can have the next slide, there's when over that roadway, there's a lot of concrete slabs, which were quite patently standing up for 100 years, and all the filler joists had rusted through, and really there's just a load of clinker which was standing up in space. And it was quite obvious it was working, but it was getting the engineers to look at it in a way that could justify that it would actually work. And what we found in the end was that whilst if you're building it as a new structure, you would do it as a reinforced concrete slab. By analysing it as a flat arch, suddenly the whole thing can work, whereas it was a dangerous structure just 10 minutes before. And this was something that intrigued us. When we came to do the brick arches, which was really trying to recreate the building as it had refurbish the building in a way that it should always have been built, we suddenly realised that there was quite a magic in what is really a pile of rubble, but if you put it in the right geometry, it suddenly becomes a coherent structure. And those brick arches there are all solid brick through and through. There's no concrete in them. And it's built as, what you see is doing the job, is actually holding the building up. I think if we can go on to the next slide. This is a building where I worked with Tony Hunt and Mark Whitby when Mark was at Tony's. And to me, this is something, again, trying to get something which is clear, which is legible, because I think engineers' first responses aren't always to provide legible structures. In this case, we like the idea of the 3-pin portal frame. This is the Patera building, which is a standard industrial unit. And we put the structure inside because it provided 1 hour fire resistance, the structure outside, so that the cladding would provide 1 hour fire resistance to the structure. But then the 3-pin portal frame is a very beautiful concept, but when you start to look at it in more detail, all the problems of wind uplift mean that all the load reversals result in a lot of bracing on the outside of the structure. And we really rejected the first responses from the engineers, and this really led to another way of looking at the structure, whereby you could get the beautiful 3-pin frame to work. And the key in it was the tie in the middle, which would make the structure perform as a 2-pin frame in uplift, as opposed to a 3-pin frame under live snow loads. And suddenly we could remove all that ugly bracing and all the sort of overstructuring on the outside of the building. And this was just the software was the thing that released the different way of looking at the building that suddenly makes it all work, whereas it didn't work 10 minutes before. And this was, in the end, ended up as a really quite a brilliant invention, which Mark patented. If we can take the next slide. Again, this is the David Mellor factory, which Mark referred to earlier. Mark was the engineer on this job. And there was another nice detail, in fact the same detail that Mark referred to earlier. If we can go on to the next slide, which is the bearing detail. And the interesting incident here was that the district surveyor came back and said that that's overstressed. It's we had it designed as a leaf spring, whereby it wouldn't impose thrust into the perimeter wall, but would the wind loads could be taken out in the plane in the direction of the wall itself. And the district surveyor came up quite rightly saying that this was overstressed, and Mark's response was to demonstrate that actually if it failed or became overstressed and deflected too much, the structure would work better. And the district surveyor in the end accepted that.
You could take a hacksaw to it and just saw it through slightly to reduce the stresses.
So, again, this is really engineering, where it isn't so much the hardware that's there. It's you've got to have the way of looking at it and the program that makes the obvious concept work, the thing that we all knew worked from the beginning. But it takes a lot more work, I have to say. But it's in the end you come up with something that's legible. And I must say that engineers' first responses are generally rather illegible structures. They work, they solve the problem, and you can design a 3-pin portal frame which has no pins in it at all. You can analyze it as a 3-pin frame, and it'll work as one, but it won't look like one. And really, there's no clarity in the way that it works. If we can go on to the next slide. Again, going back to Lords, this illustrates a preoccupation with the materials, where you have the materials in the base, which is a load of rubble which is in compression and only works because of the geometry, working up to the top where there's a membrane roof, which is just a floppy bit of canvas, which is nothing unless you hold it in tension under a very specific geometry. And again, that's something that I think we enjoy, is the fact that the materials can take on a completely different character if you apply a geometry or a way of analysing them. Taking the plate girder zone, which is just below the roof, that in that case the key to that was fire engineering, and this is really a tribute to Margaret Law of O'Larrip and Partners, who, and a lot of our buildings, including the Patera building, really owe their clarity to the fact that you can get rid of all the fire protection. You just look at it a different way. You analyse what the flame temperatures would be coming out of it. You can analyse what the stresses are, and then you can show that what is a structure that you know works in the first place and is a very clear statement will actually work. But it takes a lot more of the software to do that. If we can go on to the next slide. Again, the Schlumberger building is really just another illustration of the fabric, which is a non-structural material, except if you hold it under a very specific geometry. And the structure really there is generated by trying to build an impossible diagram. We had a diagram where you had small cellular spaces on either side and a very big open interior landscape space in the middle. And the solution isn't in the abstract. One wouldn't start off with something like that as a pure structure, but it's a response to all the requirements of the site. You've got your diagram that you have to build because it works, and you have to come up with a slightly funny structure, and perhaps more expressive than one that didn't have those constraints. We'll go on to the next slide. Again, something that interests us, this was the Bracken House competition scheme, which we worked with Mark again as the engineer, where we were trying to take the exterior architecture inside, and that was taking those Lord's flat arches in the old slab. We created jack arches inside, which are basically a flat structure with materials that wouldn't be load-bearing unless they're in that format, and that links through to the structure on the outside. On to the next slide. And this is the actual Bracken House facade, which was modified. And when we had to retain the building, you get another influence, which is the fact that you have to retain an old building. You've got materials, and there's the whole conservation problems to address. And really the materials here generated the structural form. The facade is load-bearing gunmetal on load-bearing stone. And this, in fact, it probably isn't a million miles away from centre point in terms of having the load-bearing facade. But it's something where each material has a conviction, because it is part of an overall structural system, which also extends inside the building. On to the last slide. And this was a competition, in fact, the Peters Hill competition, where we were taking the services into the facade, and the structure was bent by the fact that we had these snorkels which took the fresh air for 100% fresh air cooling scheme right down to the basement plant rooms, because we were constrained by St Paul's heights. And this created a structure which was also part of your environmental control system. And so there's no such thing really as a pure structure. It's all influenced by the structure is one element, but you have to read all the other factors that are going on at the same time. That's all I've got.
Right, thank you very much. Ron, do you have any slides? Ron? No. No, you don't. But, okay. Right. Is Cedric Price anywhere? Yeah. Do you have some slides?
I have some slides at the end of what I'm going to say.
Do they have them?
Yes, they have them.
Yeah.
Okay.
Just going to talk now.
First time.
What?
They have any slides.
No, we talked.
Right. Cedric Price. Is that loud enough?
I'd rather like I like that last contribution, sort of Pringle pudding, the mixture. I like that. The very last building reminded me of the work done by James Stott, the architect, in the 1860s in cotton mills, where in fact all the extract, rather than the input, all the extract of cotton dust laden air was carried out through the vertical columns, vertical cast iron columns, which had a great effect on their diameter, but also increased their stiffness through down to being increased as such. And the one before, the gunmetal and inevitable pink stone, was an interesting example of really paying attention to that overrated architect Albert Richardson's original building in those bay windows, the faceted windows and the pink thing. So that was dressing the pudding, whereas the last one was mixing it. And I thought the Lord's one was an interesting example of what the point we were trying to make is that you can't actually, in the terms of tonight's conference, actually define out individual elements and say add them together and then they tell the whole story. I just feel that it's been very nostalgic this evening, and I hope that most of us have a little bit of investment in the future. I thought I'd make the following points, is that I believe that engineers who are consulted by architects, such as those here tonight and they we speak about, I personally think engineers should have social intention, full stop. I also think that the direction of such intention should be assessed by the architect, not tailored by the engineer. And that's what makes you choose an engineer or reject one, and it may be what makes an engineer choose an architect or reject one. And a good example of what I mean is Peter Duncan. He made no secret of his social intentions and his appetites. I believe such engineers should have hunches, and they should be prepared to back them. I believe such engineers should delight in their own capacity to change their minds. And I think at the moment there's a danger that the dependence engineers take on various forms of computerization reduces their own capacity to change their minds drastically, as opposed to change their minds on a piece of paper. And there's a danger, I don't think any architect wants, well, let's put it this way. I think most architects would like to work with an engineer who is prepared to change the menu of a meal rather than become a bespoke tailor, which is a difference of when the alterations are made, when the decision is made. I've got a feeling that there is a danger at the moment that engineers are being driven into ingenuity rather than rethink. I'm encouraged if such engineers still hold, and this comes back to Gordon's point, still hold interest in, it also comes back to Stephen Keats' point, but they hold interest in some of these items. Now this is a very personal statement. We're keeping it 10 minutes, and I thank Roy Landau for speaking. But I'm interested in engineers who are concerned, not necessarily to finish up with it, but are concerned in structures of least weight. I'm interested in it. I'm interested in their concern about lifting and moving, whether it's in assembly or disassembly. I'm interested in their concern about shortage. Here I think one can quote Samueli. Now, whether it was imposed on him through the fact that at the end of the war and during the war, almost all materials, but particularly steel, were rationed. I'm interested in calculation, which is where I broke through when all this chat was going on about, and I think, Chris, we should take this up about Stanton, which certainly had nothing to do with concrete. You remember how the portal frames were sprung apart by... Someone died, or is that 10 minutes? You know what I mean?
It's a signal.
Right. And I'm also interested at the same time the Maison Jarre, and then the not long after the Frank UV exercise and calculated load-bearing brickwork, all of it 3 stories high, never mind the Monadnock building 100 years earlier, going up to 70 floors. I'm also interested in visible structures, which takes up Frickle's point, in so much as when he say pretty useless material unless you put it under tension, Schulenberg. Well, actually, the same sort of fabric is also a very good structural fabric if you introduce an absolutely invisible key structural element, which is air pressure, which you can flavor, it can smell like violets, and still hold the building up. I'm also interested in the limitations, which is why I had a go at, I say I was feeling rather like Oldham City then, having a go at our distinguished Mr. Sutherland, Professor Sutherland. But I do think that, that something like the Humber Bridge has been given far too little attention, and the Severn Bridge is being given far too much. I do not understand that. Engineers seem to like the Severn Bridge, and in a way, not really want to know too much about the Humber Bridge, which I find far more interesting. I'm also interested in the other quality of expediency at the time, which I would suggest is what the Fourth Railway Bridge was about. And very interesting too. And it comes on to a point which I would like to take out in discussion, is the whole misapprehension of the value of the tubular structure by engineers when they're told it's architecture and not bridge. And I think the breakthrough here is actually, fun enough, within the oil industry, the North Sea oil industry, who have advanced the whole technology of tubular structures, the jointing, the calculating of transference of stress, and in fact the value of tying what architects would see as disparate foundations, as long as the ground's deep enough and we put a tie, we don't need to tie to that level. The whole business of tubular structures, I think, has got something to do moving from expediency to the experimental. And the experimental and expediency, I think, was brought together with shortage in something which is still there. The very first one, well, I think the first one is still crossing the Trent River just by Barlaston. The second one is still at Christchurch, which I saw yesterday, the Bailey Bridge, which I think is an absolute classic. And it's the trial Bailey Bridge is still there at Christchurch in Hampshire. The construction time and the whole business of manufacturing time, which was absolutely critical, something like Bailey Bridge, is forgotten in relation to something like Humber Bridge, and certainly, to a certain extent, is hidden by architects into other timings, which I think is a great pity. And I think it's also an element that should be introduced by architects, by engineers to architects. I think engineers have a responsibility to remind architects about the efficacy of accurate timing in both design, construction, useful lifespan, and demolition. I do not think that engineers at present involved with architecture have many of these interests in heart, and therefore I think it's a rather sad period. At the start of the 90s, and all sorts of things can happen there. They meet and test it. How about the...
You've only got a couple more minutes.
Yes, I've got 2 minutes for the slides.
Yes.
I would like lastly to say that three things I'm enjoying being involved with most in relation to engineers. One is the Medway crossing. Two is a 75-metre mobile gantry, which is both parallel and radial in movement. And third is an absolutely nutty discussion I had both at Poole and in Bournemouth over the last 2 days with these people doing vertical, rigid sails for boat propulsion. Now I will have the slides. Give me a minute and a half to remind what I've just told you. Right? Yes. Yeah, he's absolutely not. Very interesting. Maybe wrong. Can we have them both on the same time? It's all right. Lifting. The assumptions as to what you lift, the height you lift it, and for how long it lifts. The only point about one on the right is that two cranes were used to build a third crane, which was high enough to put things on the post office tower. And it was higher than the three. Next. And it was on rubber tires. Don't forget what's underground, and don't forget what we're putting underground or undersea and its size. Next. Mobility. The object of mobility is less important than the intention. On the left, he liked the house, didn't like the view. On the right, 1908, a mobile Zeppelin tent, all wood and canvas, and it could move almost as fast as the Zeppelin itself, pulled by Next. Building and demolition. Remember the cost of removing the waste. Quarry Hill. Photos by Sea Price. Beautiful. Next. Urgency. Don't always wait for the disaster. Let's plan it. These, I might add, none of these slides are criticisms of architects, they're all criticisms of engineers who don't really seem to remind us about it. Next. This is for Roy, the appropriateness of design. Next. The appropriateness of siting and for how long. That's a floating island on the right, and that's a floating travelling family on the left. Next. Packaging. It's worth knowing how much the eventual product requires in its packaging, whether it's a chip or a set of goods for a quite small Midwestern house. That's it. Thank you.
Thank you very much.
Engineers, please take all of them.
Can I ask whether anybody has, other people have got slides in the projector that I don't know about? Has anybody else got slides here? Ah, Mike, would you, 'cause
I'll talk for even less time than Cedric. I'm going to face the wall to see what's
I didn't take long. I took 10 minutes. Watch it.
okay.
Well, really just a series of questions and things I like. 1509 to 1515, John Wyatt, the fan-vaulted roof at King's College, Cambridge. Why did he do it? I think he did it because it would be beautiful. And I think he did it because it performed the task that he set out to achieve. Next. 1851, Decimus Burton. Why did he do it? I think he did it because it was beautiful. And I think it set out and achieved the task that he intended. Next. The most important house built in the 1960s in the world, Steve Baer's house, which is the precursor of the second industrial revolution. This was a steam radio valve version. We're talking, of course, about the electronic revolution, and this was the manual Victorian way of trying to attack the problem that we're now really trying to grapple with. Why did he do it? Because he was fascinated by the structural system. He was an engineer. The house is built from, the zone system, and he did it because it was beautiful, and he did it because he was concerned about its performance, as did John Wyatt and Decimus Burton. So I would offer the notion of performance as a judgment of structural quality. Next. Discontinuity here, of course. Lloyd's, our own building. Why did we do it? Performance. And not a direct link, I have to say, not because it's beautiful, I have to say, but we're finding it increasingly difficult to separate a mid-blue custom-coloured piece of steelwork, which we call structure, from something which we might call servicing, from something we might call floor slab or space. In other words, we see them increasingly as integrated systems. We find it very difficult to see them as separate pieces. So we're wrestling with the problem of integration all the time. And here, the reason for Lloyd's is that plan. That plan is what generates everything else in the building. That is what Lloyd's is about, that plan. And it's about performance and growth and change over time. The ability to accept that certain parts of that structure will be expressed in different ways according to what they will be doing over the next 150 years. Or 10 years, depending on how long the building will last. We certainly didn't intend the coloured pieces to last a long time in their current form. In fact, somebody, I think last night, in fact, raised the issue of the problem of Lloyd's when it's listed, as I'm sure it will be in the end, and what you do with all these changeable elements on the outside of a listed building. I think our solution is to list all the elements separately. Next. Just, again, an illustration of the performance. The middle slide on the right really illustrates the yellow, which is the main block of the building, which is the human housing element, and all the blue is just that which supports it. Next. Again, performance. Conflans-sur-Montarine, a skating rink, beautiful little structure. It's been around for a very, very long time by Keppelek. A bat lives in a hole in the ground, and when the sun comes out, the bat automatically rises, stretches its wings over the stadium area, and covers the ice to keep it out of the sun. And everybody carries on skating, and when the sun disappears, it disappears back into the ground again. Of course, to great cheers from the crowd as it happens.
Get a word from Jenny Lowe. and maybe a word from Peter Salter just towards the end, if you would agree to that. So, could I first of all perhaps go to Robert Thorne, and ask him if, I don't know whether you particularly want to address these issues, but it would be nice if maybe we could round some of these questions up.
I'd just like, as the only historian in the kind of front stalls, to pick up on a couple of things that people have said this evening, and to reflect very briefly indeed on the character of this event. First, I think as a historian I can't accept Mark Whitby's proposal that structural expression is always with us, nor can I really accept Ron Heron's proposition that everything's going on at the same time, because I think you called us all here this evening in recognition of the fact that something rather special has happened in English architecture in the last decade or so, and that it isn't just simply a rehearsal of things that have been going on for a long time. It draws on certain antecedents and a certain pedigree, but something unique has happened in the 70s and 80s. And I wonder whether it's a uniquely English thing that's happened, and whether this event, this gathering here this evening, could be happening in any other country, particularly whether it could be happening in America at this moment, and whether this particular dialogue between architects and engineers is special to an English environment or not. And above all, I want to think for a moment about one group of people who, until Mike Davis stood up, really hadn't had a look in at all, namely the lay public, and what they make of all this. Not what we here at the AA make of it all, in a contented way, but how they are responding to the Lloyd's building, to the Renault warehouse in Swindon, the in-laws factory, and so on and so forth. On that last matter, I think this movement of structural expression, and it is a movement, something very special has happened over the last couple of decades, is a genuinely popular movement, because it does draw upon a certain public view of our nation's past, and particularly it draws on that tremendous affection that the public have for the intelligibility and the visibility of the objects and the buildings of the first part of the Industrial Revolution. To that extent, what we're all involved in today, or rather what all the engineers and architects who are before us here today are involved in today, is a very nostalgic movement. Not perhaps nostalgic in quite the way that Cedric Price was mentioning, but because it's drawing on that past and on that affection. It is a railway lover's architecture. Does that mean that in moving forward, you asked about where are we going to go next, we should actually draw on that past even more explicitly. We should make even more reference to the 19th century past, particularly the English past, the Industrial Revolution. I think most of us in this room are going to say no, and we travel around this country in fear and loathing of seeing another reproduction of the Crystal Palace transept appearing above a building, and that the way in which we should feed upon this and support and further this genuinely popular movement is by, looking fruitfully at those past forms of functionalism, rather than just simply rehearsing them all over again and repeating them, because I think actually repeating the Crystal Palace transept is just as dull and as unfruitful an experience as repeating Palladio in Dunham College.
Thank you very much. Kenny, would you like to just add anything to this summing up?
I'll try, add a little. It's a bit difficult, I think. There's such a lot that we've said, quite a lot of which I agree with. I was going to try and pick up I don't know how many people had this paper on structural expression forums. There were lots and lots of points there, most of which I don't think have really been addressed or answered. I'm not going to try and talk about many of them, but I'd like to talk a little about a couple of them. Because there is this business of high tech, and one of the architectural journalists, I suspect, coined it about somebody's architecture and structure. I don't know whether it was Colin Buchanan. Somebody might tell me who wrote this marvellous high-tech thing first. I don't think the structures that we're talking about, any of us, are actually high-tech. I think it's a style label that's got stuck on the structures, which I think is a bit unfortunate. They are technologically sort of competent and appropriate to our time. They do, some of them, look backwards towards the Victorian structures that you've just been talking about. I think that's unavoidable in a way. Engineers are influenced and affected, I think, by what's gone before in all sorts of different eras, some of which we still consider to be, very important structures. But going on from that, the only person who really talked about the future was Mike Davis, I think, in any sense at all, and I think that's interesting. Lots of people have been harking back to the distant past and the near past. He talked about the future, and that's the thing that, as an engineer, I'm very interested in. He talks about new materials, and I'm quite certain that, in fact, we are going to be using different new structural materials as and when appropriate. I don't think for the fun of doing so, although it's sometimes quite a challenge to look at using different materials and structures. Cost will always come into it, and at the moment the cost is prohibitive, quite often, for some of those new materials. I'm rambling about because I'm sort of slightly lost, because so many people have said so many things and it's a bit late, and I expect we'd all like a drink in a minute, and it's very hot in here. I do believe very strongly myself in what I call legible structure, and I think other people have talked about it. Not legible necessarily to the point where it's dominant, although I think some of the structures we've been involved in have been somewhat dominant. But I would like to think that all the structures for the buildings, or certainly our best and favourite buildings and structures, have a legible and appropriate structure. And I think it's very important, no matter what the material of the structure or the form of the structure, that it actually is appropriate to the building. Because buildings actually are about synthesis of structure and architecture. And as Mike said, they're for people, of course. All buildings are for people, I guess. I think the thing I'd like to conclude with, really, just another comment, that people were talking earlier on about why structures looked as they did, why some structures seemed to be satisfying, whether they were minimal structures or whether they weren't. And I think that the satisfaction of good-looking structures, if I can put it that way, is actually to do with their geometry and their form and their proportions and the relation of certain parts to other parts of structure. Sounds a bit like architecture, really. And the way in which those materials are used generally, and certainly, of course, as Mark was talking about, very much the way in which you join parts of your structure together. And it's all these things, and it's terribly difficult to even begin to talk, in particular this time of the evening, I think, about why some structures are really very much nicer than others, to use a horrible word, because they are. There's no doubt about it. Some structures are nicer and they're more beautiful and they're more satisfying than others. And I think a last thing to say is that because structures are usually part of buildings which are designed by architects and engineers and other disciplines as well, the buildings and their structures which are best generally come out of the sympathy that some architects and some engineers and other consultants have working together. And I think that's perhaps one of the most important things. If you all work together as a team and you understand about one another and have common aims, you may fight like crazy, and you do, actually, but in the end you get better buildings, and I think you get better structures as well. Thank you.
Thank you very much. So perhaps we could just round off this evening with some comments, just a few comments if possible from the school. I wonder if I can ask Jenny to have a quick thought about this question and how you feel we were relating to it here in this institution.
I mean, I can only speak for myself.
Well, absolutely.
It would be great if there was an opportunity for other people, especially students, to perhaps express their own opinions. But I think if one takes the theme of structural expression, perhaps even separating the two words, I think the structural aspect, structure as such is a very simple thing. It's a way of transmitting loads to the ground because of this condition that we live under called gravity. Now the way that that's done and how it's done is okay, maybe it's infinite, maybe it can be pushed as far as it goes. But where it perhaps becomes interesting is when you start to introduce the word expression into it as well. And again, it's then within that word is what is trying to be expressed, which might, which is a wide open thing, and again is very linked not only to the kind of pragmatics that architecturally are being dealt with, structure being one of those, but is also the kind of socio-economic, cultural kind of climate within which one is existing, and the notion or the aspirations perhaps through that kind of expressive use of structure, and how that links back to the kind of cultural expectation or cultural defiance of a culture that might seem to be stagnating and wants to perhaps be regenerated or questioned or challenged in whatever way, that in a peculiar way the use of structure and the nature of structure, the nature of the materials involved in the structure and the choice of those, then starts to become a kind of interesting conversation. But again, it depends on what the nature of the expression is, of what the motive is. And again, I think within the school, and there is a lot of use of structure and respect and manipulation of structure in a lot of, depending on where it's coming from, the different positions being taken. That's very important and seen as kind of a very important kind of aspect of the work in the school, I think, in various schools. But again, it depends on the position that one takes, the intentions that one has of it, the expression that one wants to make, the position one wants to take, which again links back to a kind of cultural aspiration of the moment. And to a certain extent, I think within the school, if you can stay in touch perhaps with some kind of leading edge as to what those kind of aspirations of the culture as they're living as young people at the moment are starting to formulate in architecture, is that it's very important. And then the kind of inventiveness and the choice and use of structure and how it's used, how it's manipulated, that's become very important as one of the aspects of what architecture has to deal with. But again, it's one can sort of talk. There's certain aspects that I found really kind of depressing. I found really those last two buildings in the way you were describing them kind of very depressing. And I'm not quite as polite as Cedric, but I wonder kind of, at the end of the day, with the CFIT couldn't kind of conform to the plans of London, the City of London or Islington as an appropriate kind of way, without, nice ideas, but at the end of the day. And again, it's how the integrity, and I'm now involved in working in a kind of world that's having to confront a lot of that sort of stuff. But again, it's the sort of persistence with which one is going to be using those ideas, if it's going to start to inform the architecture, how it informs the architecture, and what kind of aspirations, cultural aspirations that it's actually taking. So, and again, that's...
Okay, well, I suspect this evening's not going to give us the opportunity of resolving the problems and the likes and the prejudices and feelings that we're going to express, but I think, could I ask Peter just to...
Yeah. Again, I can't speak on behalf of the school because there's so many factions within the school. But I've been involved in technical studies in the school, and I'd just like to explain or tell you about what has been going on.
Can you speak a little bit louder?
I think the first thing that really started to come out here but wasn't really examined enough was that I believe that that all structure has to be related to its architecture. The structure, I think, now starts to take its place in terms of the enclosure. I think that the structure starts to be used for pacing, for pausing, for changes of scale, all of those things beyond its job of holding the enclosure up. And over the last few years, there's been a want for a structure which is perhaps more responsive in the same way that perhaps the building envelope is more responsive, or space is more responsive to its context. And therefore the structures have started to become perhaps more shaky and all of those things. And I think has come about because people, certainly within certain units in the school, are now dipping into other things, dipping into other disciplines. They're not always looking at precedents. They're dipping into other disciplines, and so there's things that have been dipped into recently have been things to do with skeletal forms, maybe the other applied arts apart from architecture, all with a want to get some responsive structure, responsive buildings that weather, buildings that change, buildings that mark time in some way. And the AA, during that period when everyone we were looking at, just one other point, also that many of the buildings that were looked at in recent years have been asymmetrically planned spaces. And I think that's very important, because if you have an asymmetrically planned space, you can't have a symmetrical structure. And so all of a sudden we start to think of asymmetrically planned, asymmetrical structures, leaping structures which just about, hover above the ground. And I think all of those things is about what structure's about. And I too like to know the difference. Well, I have a personal feeling about the difference between high-tech and expressionist architecture. I don't think expressionist architecture is high-tech. And I think that high-tech architecture, and I think they both have their place,
I've never seen any high-tech. Show me some. I'm dying to see.
Well, I think there's high-tech architecture. I think there's high-tech architecture where the material of the structure starts to be metamorphosed into becoming the skin.
That's just good technology.
And I regard that as high technology. Real high technology lies in mountain bikes. And milling.
So they're both valid in different cases.
And lies in carbon fibres of boat construction and of tunnel construction. But you can't say that is expressionist.
Well, what raises the difference between high technology and new technology? I just think it's new technology.
Well,
some of it's high, I guess.
I can remember going to the top of the Tour Montparnasse in Paris, and they were stripping out the Otis plant room, and they were stripping out the electronic components, and they were stripping out the electronic components and replaced them by brass wheels with cams and levers. And they were doing it because when the system broke down, nobody could understand what went wrong with it. So they found that you could send up the old man in the boiler suit and he would fix it, because you could see that the can was broken or the pulley was missing. But with the black box, nobody could do anything about it. And so 5 or 6 people, several weeks of analysis and so on. And the architecture of the electronic age, the iconography, is not yet with us, and that's what this school is going to be facing in the next 10 or 15 years, is a new architecture based upon the second industrial revolution. And I think that's something to look at and to look forward to. It may include structure and new elements and new materials, but it also includes things that Gordon and Cedric have been looking at, which really are issues of information. And I think that the gap between building as passive object and human as active object inside will blur. And the buildings will do much more than they are now. They'll become intelligent in my sense of the word, not the Arab sense of the word, and basically they'll close together. And I think that's what's worth looking at in the future and worth everybody having a doubt.
Right. Ron, would you just...
Well, just one point. I think that what always amazes me is that these two disciplines, one that's so precise and mathematical, and that is actually taught as pure maths, Frank, yeah? Well, I think
that's the biggest illusion of all time.
But maybe I'm using the wrong terminology. But as I understand it, engineers, certainly at Cambridge in Frank's time, read mathematics and did not design. And I don't know how many engineering schools get involved in design now, and I bet you none.
No, two.
Bath?
Yeah. Leeds and Bath.
Bath and
And neither of them enough.
Yes. And it just strikes me as extraordinary that these two disciplines, one that concerns it totally, itself almost totally with what things are like, what they're like to move through, what they're like to sit in, sort of poetry almost, which is almost impossible to describe. We all struggle with silly words and make very precise drawings. And we're talking to people who don't often understand those silly words and those stupid descriptions, but tell us that's not making structural sense. And so often the architect is reading this structural expression incorrectly, 9 times out of 10. I would guess 99 times out of 100, until someone like Frank says, hey, hang on a minute, this isn't as precise a game as you think it is. But it's interesting that these two disciplines spend such a lot of time working together and misunderstanding one another, and that occasionally it produces things that are quite extraordinary. That's all I...
Right, well... sorry.
I just want to finish off. There was an engineer in Arabs called David Tomlinson, who was the engineer on the Bath University building done by the Smithsons. And he was... That relationship between engineer and architect was absolutely amazing, because he, you know, we would be talking about some kind of structural solution, and he would turn around and say, but that's not the rigor, that's not the strategy that you told me about. That's, you know, it's a different set of rules. You've got to start behaving according to that strategy, according to that rigor. And I think that's wonderful. And really good engineers and really good architects can start to knit these things together, and it clicks, and I think it's wonderful.
Okay, well, yes.
Can one make an observation?
Please, yes.
To some extent, we seem to have got a little bit retrospective, and I've noticed we've highlighted part of what I would think of as being the magic of engineering, it being very much a process of discovery and invention. Whereas we've turned and looked so much at objects as structures, rather than the process of not knowing quite what to do and coming up with a peculiar idea of taking water in beings through a very improbable route. So what one's trying to say is that maybe if one looks retrospectively, one does look at objects and physical structures as we've talked about a great deal, whereas maybe if one looked more in contemporary terms, one would be more process orientated and not necessarily looking at a finished object, but possibly an unfinished solution, and be in a process of invention, possibly discovery, and maybe is it that one has the impulse even to want to express or leave as a new form of entity, be it a physical structure or be it an organizational structure, that, again, retrospectively, someone might call structural expressionism.
Right. Yes. I think we could have just about 2 or 3 more contributions, and I do think, just from a time point of view, that we're going to have to. So please.
Yeah, just a little bit about this high-tech notion.
Yes.
With the use we went last year to, amongst other visits, to tube workers, it's a company that fabricated the star-stud trees. And the way back a student asked me, and it was very nice, he said, why do they call it high-tech? It's really so crafty. Because he stood there and he see how, he said, we went there and saw how day after day a piece of, welding is made of these huge, there was a huge half a bridge of Birmingham. And to see how it's made a day after day, but it really gets filled craftily. And that was a very nice question. But I think, again, to these notes that were here, both from Mike and Peter, I think it's really more to do with, I think we're dealing more to do with, more than dealing with expressionism or functionalism, structure. We're dealing really much more with the craft of the beautiful. And I think that's what is us more.
Well, thank you very much. It seems that everybody is now feeling an anxiety about the trains or something. So, on this wonderful note of rigorous imprecision, I think we can now leave our session for the evening, and I want just to thank you very much all indeed for coming, and thank our speakers especially for providing us with a wonderful evening. Thank you all very much.